Hey everybody, welcome back to the channel. This is the second part in my remote imaging 101 guide, and in this video I'm going to just talk about how you're actually going to operate your remote telescope. So what we're going to do is we're going to cover how you're actually going to log in and access your remote setup, how you're going to just do a basic sequencing or automation run in Nina, and then I'm going to discuss how to get your files off of your remote PC. And the hope is by the end of this, you should feel comfortable with doing whatever it takes to actually do your astrophotography with your remote setup. Your remote astrophotography setup can be controlled by two possible things. You could have a PC, or you could be using an ASIair. And I know I'm going to be neglecting smart telescopes for at least this episode, but we'll cover that at another point. If you're using an ASIair, the method which you use to connect is actually pretty simple. What you'll get from us at our observatory is an OpenVPN config file, which you will just load into the OpenVPN app on your phone. From there, you can access your ASIair as if you were right here in person with it at the observatory, and then run your whole imaging system exactly as you would if you were out travel shooting, except in this case, it's permanently installed at the observatory. For your imaging PC, if you choose to run off of a mini PC like an Eagle or a Beelink or a Melee Quieter, the way you can connect is a little bit different. There's many different options for remote desktop connection softwares, and we've tried many of them here at the observatory. We know which ones fail and which ones don't. And from what we've determined, the best solution for everyone is to just use Chrome Remote Desktop as a remote connection solution. Chrome Remote Desktop is free. It only requires that you have a Gmail account. So you need to set up a Gmail account if you don't already have one. And then you just install the Chrome Remote Desktop client on both your imaging PC and your home PC. And this program is super, super stable. I've been using it for many years. It even has a good phone app, and it has just never failed us. It's so good that if you do it in advance, you get everything set up before sending your system out here. The only thing we have to do to get your system online for you to be able to actually log in is we only need to connect your computer to Ethernet and power, and then you'll be ready to actually boot into your PC without any extra work from us. So we definitely recommend that solution, and I'll just show you how to get that set up now. All right, here in my RV now, and I'm going to give you a demo on how I actually go through and set up Chrome Remote Desktop. Again, you're going to want to do this on both your main imaging PC and your home desktop computer. If you do this, all of your remote connection problems will disappear. It'll be great. All right, let me show you how. Okay, so now I'm in this guest browser of Chrome, and here I've gone to remotedesktop.google.com. Now this is where we're actually going to go to download the client and access our systems. So what we're going to do is we're going to click access my computer, and then we're going to either log into our Gmail account or create a new account. I'm just going to create a new account for personal use here, just for fun. My name is Freyballs. I can't believe that email account wasn't taken. Agree to all the terms and services, blah, blah, blah. Just go through all of that. Cool. Now we're at the page where we can actually download the Chrome Remote client, which we'll use to do all of our stuff. So we'll go ahead and hit download to set up remote access. Add to Chrome. I've already done it, so I guess it's already showing that this is completed. Sometimes this glitches out here and it won't actually download a file. You just have to keep refreshing and hitting the download button until it goes through. And once it does, you'll get a little, it'll be like a little MSI file download that, and then once you get that downloaded, any computer where you can log into that email account you set this up with, you'll be able to access via Chrome Remote really easily. So you'll just want to do this both, again, on your imaging PC and whatever you intend to run the system on. You can even set this up with the mobile app on iPhone or Android, and it's really, really, really nice to use. By far the most stable. Now I'll show you, once you get this set up, how do you actually connect into your system, because like I said, I have a bunch of telescope systems that are operating off of this, and I'll show you how I actually log in, to run them. So I'm going to come up here to my little Chrome widget for Chrome Remote. Again, you can also just type in remotedesktop.google.com/access. And here you can actually access all of your different PCs. Now you can see I've got a ton of them here. I've got all of my remote systems. This one is a FSQ85 in Namibia. So I can log in and see what the telescope is doing wherever it is in the world remotely. And here this telescope is currently actually doing some imaging, which is cool to see. And again, I can log into my system in Chile in the exact same way. Depending on the Wi-Fi speed where the scope is, it'll be slower, but here we go, another system. If I want to log into my triple Rasa system at Starfront, it's right there for me as well. All of these systems are just a couple finger clicks away, super easy to access, and this connection is going to be super, super stable. So I really highly suggest you do this before you send out a remote telescope anywhere, whether or not it be Starfront or here. This is going to make everyone's lives way, way easier. So now that you know how to do it on a mini PC, I'm also going to show you how we set up this VPN configuration if you're using something like an ASIair, because there's a lot of people at the observatory running the ASIair. So what you're going to get from us is a OpenVPN certificate file for Starfront observatories. And what you're going to want to do is download this file onto your phone or computer or PC, wherever you're actually, planning to run your system. So I'm just going to go ahead and save this into a folder on my phone, which I'm going to name Starfront, and that'll be Starfront OpenVPN. So you'll want to go into your files wherever you saved that zip file here, and we'll click on it just to unzip it, and then we'll get our OpenVPN certificate that's not as a zip file. And then what I'm going to do is open it up in OpenVPN, and then we can now add this as a standard profile. And then we'll give ourselves our username. You'll receive a username and password, by the way. So this is one I have been given in advance. I'm going to hit save password, and I'm going to go ahead and type in my passcode and hit connect. And I'll say allow new configurations. We'll add in our phone's passcode, and now we are connected into the VPN. And once you do this on your phone, now you can then proceed to the ASIair app and actually connect to your ASIair as if you were right there with it in person. So super easy to do. You don't need to learn Nina or any of that fancy stuff if you have this, because you'll be using the ASIair just like you would while travel shooting. Now later in this video, I'll also explain to you how you can get data off of the ASIair, because it's a little bit more complicated than with Nina, but still not too hard at all. Okay, so now that we know how to actually connect into our remote telescope setup, I'm going to show you how to set up a basic profile for Nina to actually go ahead and run your telescope in an automated sense. I'm also going to show you how to connect to our roof files at the observatory. Chances are, if you're sending a remote telescope out here, you already know how to do an automated imaging setup, but this will just give you a refresher, or perhaps you're totally new to it and you want to see how it's different. It's not any different when you're doing it remote, but regardless, I will demonstrate. And for ASIair users, it's the exact same. Okay. So just to start, for actually setting up, the really only differentiator between a remote Nina setup and a local Nina setup is if you wanted to connect to our roof status. So I'll demonstrate how to do this. The first thing you're going to want to do is download the generic ASCOM file safety monitor driver, which you can find, just off of the ASCOM website here, generic file safety monitor, and this will let you monitor our roof status file, which basically tells Nina whether or not the roof is open or if it's closed. So you're going to go ahead and download the zip file for this, and then you can unzip it and set it up. I have not done this yet, so I'll go ahead and extract it, and I will run the generic file setup. We're going to run this anyways, even though it thinks it's a virus. I'm going to make sure OBS is recording. And we'll go ahead and hit install. Cool. Now that that's done, what we're going to do is I'll show you how to set up the network drive for connecting to the roofs. Okay, so this scope that I have that I'm demonstrating on now is inside building 2. So I'm going to show you how to map the network drive. So we're going to come to these 3 dots here and we're going to say map network drive. And then I'm going to connect this drive to the IP address for buildings 1 and 2. So I'll do my double backslash 172.23.17.165 backslash SFRO dash customer. I'll reconnect it sign in and we'll say finish. And there we go. Now we're straight into the roof status for buildings 1 and 2. If it did prompt you for a username, it's just guessed and there's no password. So that is actually how we boot up the network location for the roof status. Okay, so all of that setup is now done and we're going to go ahead and set up a little Nina profile and get it set up for remote imaging. So I'm going to double click Nina here and I'm going to start up a new instance and we'll work through the setup together. I'm going to use an existing profile and just show you how I work through setting it up and show you what you need. So working backwards, I'm going to start with the safety monitor here under equipment all the way down to safety monitor, and we are going to select the generic file safety monitor and we'll hit the settings for this. And now we can set our event types for the roof open or close status. So one thing we'll need to do is select our file to monitor. So I just clicked on that dialog and it's going to boot up the file explorer. And we're going to go to that network location, go into roof, and then find the building that you're installed, and then select your roof status file. That is where the roof status is going to post. And then we can decide, how often we want to monitor this file for open or close. I'm just going to do every 3 minutes. It doesn't really matter too much. It takes like a minute and a half for the roof to open or close, and I believe the weather patterns are on like a 3-minute refresh. So we're just gonna set it to 3 minutes. Why not? Our trigger for safe will be open, and we will add this as an event here. And likewise, we want to set a trigger for unsafe, which is going to be close, and we'll go ahead and add that. So now we have our open and close triggers, and all of that is set up. I'm just going to turn trace on. I usually turn trace on all my ASIair drivers just because it helps on the log files to have that typically. So I'll hit OK, and then I'll hit connect. And now we are connected to our roof. And we can actually see right now that condition is not safe because the roofs are literally closed because it's daytime. Cool, so that's really the only thing that's going to differentiate a remote setup in Nina versus a local setup in Nina. But for those who aren't familiar at all with using Nina, we're just going to set up a basic imaging run. Your remote setup is going to have all these different components here, starting with your camera. Then you have your filter wheel, focuser, rotator, mount, guider, switch, etc. So what you're going to want to do is, of course, download all of the associated drivers to all of your equipment. If you have a ZWO camera, you need ZWO drivers. You need the ZWO filter wheel driver if you have that filter wheel. Same for the focuser, same for the mount, and everything else. So you just want all the drivers associated with your gear. And once you have that, you can go through here and look for your camera that you have. If you don't see it, you can hit refresh, scan for devices, and then select the proper device, and then hit connect. I do not have a filter wheel in this system, but if I did have a filter wheel, I could go and connect it as such. Likewise for the focuser. Here in the driver, I'm going to hit settings just to open up the ASIair driver, make sure this is the focuser I want. and it's not because I have 3 of them on this setup. So we'll connect the focuser. Here's my mount. You see I have my mount driver, which is just on the on step. We'll go ahead and connect the mount. This is our auto guider program. And if you aren't familiar with auto guiding, you should get PhD2. This is kind of the industry standard auto guiding program. It's going to work the best. So download PhD2 if you don't have it already. You can, again, connect it there. The switch flat panel, if you have a flat panel, here's the place to connect it. Everything else, you are done with the setup, at least for your equipment. Now, when you are actually dealing with some of the other tasks required for automated imaging, you're going to want to go here into the options section to work on configuring some other things. Nina is going to need to know a bit about your system, things like the pixel size here. Specific to your camera, you'll want to look up what it is for your camera and type this in. You're going to want to import your telescope's focal length as well. So just figure out what model you have and plug it in. The rest of this stuff I leave alone. Your autofocus settings. We will cover this more in depth in the video about doing the astrophotography in a more advanced way from remote, like your exposure times, all that stuff we'll discuss later. But here's where you would configure your autofocus settings if you've never done it before. Here we have some imaging settings where we want things to write. All kinds of advanced settings we may want or not, including our meridian flip settings. I've left these on defaults and it's gone fine for me. For plate solving, I like to use ASTAP as my plate solver. It's very, very fast, so I would suggest that you go to ASTAP and download their plate solver. If you want to use a blind solver as a backup, let's say ASTAP fails to plate solve your image for whatever reason, it can be good to use astrometry.net as a blind solver and just let it do an all sky plate solve. This is a pretty good idea. And if you want any plugins to, run your telescope, there's tons of plugins in Nina here that you can use to get as advanced as you want to be for imaging. So lots of different tools that we can do to actually run our telescope. Now, one thing you'll also want that I really enjoy to have on any of my remote systems is a good planetarium program. And I prefer to use Carday's DoCL just because it's very bare bones, it's very basic. I don't like something super resource intensive when I'm doing my imaging. I just like something dumb in the background that gives me all the functions I need. So this is a good program. It's useful for getting comet data, seeing where your mount is pointed, where it's going. It's just a really nice free program for organizing that information and doing a little mount control. So I recommend downloading it. Connecting your equipment to it is super easy. Just go telescope, connect telescope, and then select your driver just as you did in Nina, and then you just say connect. And then your mount is going to report its position to Carday's DoCL, and you can see where it's pointed with that little circular crosshair there. And that is all the software you should need to go ahead and get started with imaging. Now it's clear for me tonight here, so we could set up a little imaging run and go for it. I'll go ahead and demonstrate how you can set up a run using the basic sequencer for the purposes of this video. So if we wanted to find an object to shoot, we could give it a name here in the Sky Atlas. So we'll say, let's go shoot M31. I'm going to go search M31, and now we can see we have an option here for an object to shoot. What I'm going to do is set this for the framing assistant. And now what it's going to do is it's going to pull down a survey image from the HIPS2 sky survey, and it's going to project our field of view onto the sky survey so that we can plan exactly how we want our framing to be. And this is why it's important to get your camera's focal length, pixel size, and image dimensions in advance here in your options tab, because this lets you see what your field of view is actually going to be like when you go to take the photo. So I can use this to plan out exactly what I wanted to shoot. Like so, I say, oh, I like my framing there. If you don't know what your camera's rotation is, it's going to guess that it's 0 by default. but you can see if you have a rotator, you can change this to whatever you want. Or if you don't know what your rotation is at all, you can hit determine rotation from camera, and it's going to do a plate solve on wherever you're pointed at in the sky, and it's going to sync your rotation to whatever it is. I know that mine is very close to 270, so that is going to be what my real field of view looks like. So now what I'm going to do is I'm going to add this target to the legacy sequencer. So now we have a whole bunch of options for what we want to do for our imaging run tonight. We have our target set options for the start, and then we have our end options. So at the start of a sequence, I would like to cool my camera, unpark the mount, and I definitely want to be able to meridian flip. So all that's going to be on, and when we're done with the sequence, I would like to warm the camera and park the mount. So now let's expand our target and autofocus options. We definitely want to slew, we definitely want to center so we get our perfect framing, and we're definitely going to start our auto guiding. For autofocus, I'm definitely going to focus on the start, and you can do many different options here for when you want to trigger a new autofocus. If your stars start to get blurry, you can trigger it. If the temperature changes, you can trigger it, and after elapsed time, you can also trigger it. And you can run any of these as needed or as desired for your system. Depending on what your system is, you might find better success with one of these. Oftentimes, I just leave mine at refocus every 30 minutes. So now that that's set, we get to decide what our imaging plan is going to be for the night. And let's just say I'm going to shoot several hours of exposures here. Let's just do 60 5-minute exposures. So that's 300 seconds for 60. And I'm going to turn on my dithering because I like to dither. And we can decide how often we want to dither right here, or if we want to pick our filters, or if we want to choose our binning. All of that we can decide here, and even set new events. So if you had multiple different filters you wanted to shoot, you could just add new events and then go ahead and set your exposure plans for that. And then all you need to do at this point is hit run, and your scope is going to go off and do that pre-prescribed imaging plan. The one thing that you should always do, if you can, when you're running your remote telescope, is home your mount every single time before you use it. This makes sure that your scope is where it thinks it is, so that when you go off for your first slew, you don't just crash into your pier. If you don't have a homing mount and you have a pier camera, you should check every single time before you run your telescope that your scope is actually where you think it is, especially following the night after a power outage, or if your sequence did not end normally. If your sequence didn't end normally the night before, this is a big red flag that your mount isn't going to be where it thinks it is, and you either need to check it or you need to home it. So make sure you do that, because I don't want to see your telescope crashing into its pier. Okay, so one of the most important parts about running a remote telescope is how do you do your calibration frames, whether that's the flats, the darks, the bias, and it's actually really simple. We'll start with the most complex one, which is the flats. At least people think it's the most complex. But here in Nina, it's actually really simple. So just as we described earlier, we have all our equipment connected that we're going to use. And if we want to go ahead and do our flats remotely, I'm going to show you how to do sky flats. So all we have to do is go down here to the flat wizard, and we'll hit slew to zenith. Of course, our mount is parked, so I have to go unpark the mount first. Okay, slew to zenith. So now the mount is going to go take off to zenith. One question people have a lot is, don't you need a white t-shirt over the front of your scope if you're going to do sky flats? And the answer is no. As long as the sky is clear, the field is very flat, and you don't need a t-shirt or anything else to diffuse any kind of stuff in the field. If you want to check what the skies are like, you can check the status page on our website, and it'll show you what the skies are looking like. But if the roofs are open, chances are it's good to do sky flats. And you don't even have to do them like I'm doing them here. You can have them automated in the advanced sequencer, which I'll show at some point. But the scope is at zenith now, so all we have to do our flats is hit the play button. And that's literally it. So what it's going to do here is it's going to cycle through some exposure brackets until it finds the optimal flat frame exposure, and then it's just going to do the flats. It's really that simple. And then we'll be all calibrated and ready to go. When it comes to bias and dark frames, the way we do them here is if you have a flip flat, you can just close your flip flat, and then on a night where it's cloudy or the roofs are shut, you can go ahead and do your darks and bias with a flip flat without any intervention from us. If you're using a setup that doesn't have a flip flat or any kind of automated cover, what you would do is either submit a ticket with us to install a cap on your scope to allow you to calibrate, or you just need to sign up for our monthly full moon calibration list, where I put up a Google sign up sheet every single month for people that want to have their scopes covered on the full moon to do calibration. And I'll go through and cap up literally every single telescope on that list so people can do their darks and their biases without having to worry about any kind of light leak. This is just going to be a quick demo of the imaging plan we set up earlier in Nina. I'm going to just show you how that actually proceeds once you hit the run button. I'm doing it here with a different telescope because the triple Rasa I showed earlier is preoccupied, but it'll be the exact same. So we have our whole imaging schedule set out in the legacy sequencer, and I just have to hit the run button here. And now the scope is going to go off and do its thing on Andromeda. So the first thing it's going to do is that slew and center on the target. I'm sure a lot of you are already pretty familiar with this, but if you're not, this is what your telescope does when you hit the button. So it's going to use ASTab to make sure it's pointed on the framing we talked about earlier. There's our first image of M31 and it's way off. So now it's going to do a plate solve. All right, now it is pretty much centered, so it's going to start the auto guider, but as you can see, we're pretty far out of focus, so it's going to lose its mind for a moment. I'm going to go ahead and stop the auto guider and reselect a star, and Nina's going to push now into the autofocus run. Okie doke, the autofocus run is done. I'm just going to make sure the scope is auto guiding really quick because it failed at that. And now we just sit around and wait, and the telescope is going to do all of its imaging. It's going to go for the next 5 minutes before we get a subframe, but this is just a simple guide showing you what happens when you use the legacy sequencer in Nina. Okay, so now it is the morning after. We've done a successful night of imaging. How are we actually going to get our data off of our mini PC or our ASIair and bring it home to our editing PC locally? Now I'll start with the ASIair because it's pretty simple. Just like how we mapped the roof server earlier to a network drive location, you do the exact same thing with your ASIair. What you'll receive from us is basically all of your VPN and IP detail information that you need. And then what you'll do is you'll use your ASIair's IP address that we provide you and map that as a network location. Now this will give your PC the ability to access the hard drive and the memory on the ASIair remotely as if it was, you know, a NAS or some other kind of network attached storage. So just like we did for the roof server, you're just going to map a network drive in the same way, and you'll type in your IP address here. And I think it might also need your ASIair's passcode, which you will know from whatever it is for your ASIair. I don't have an ASIair on our network to set up, so that is all I'll be able to demonstrate, but that's all you really need to know. And again, if you have any questions or you encounter any difficulties, we do have a channel for this on our Discord server where people can help get you sorted if you run into any issues. That's how you do it for the ASIair. If you're using Nina, then you have a whole host of different options you could go with for file transfer servers or services, whatever you want to call it. I like to use Dropbox for all my file transfers. And what I tend to do is I will just write my files from Nina directly to my Dropbox folder so that my files are moving over to my editing PC as they're captured. And if you're at an observatory like Starfront where the Wi-Fi speed is really, really fast, then this is totally okay to do. I mean, you'll get your subs within seconds of capturing them. So the way that I do that is I'll configure my options here, my imaging options in Nina, and I'll set my image file path to a Dropbox folder. And I actually haven't done it yet for this NINA profile. So I'll go ahead and do that now. And I'll go ahead and now write all of my lights. All the files I capture are going to go straight to Dropbox, and they'll automatically get synced to my capture or my editing PC. And here there's a little widget for Dropbox. Down here in Windows 11, you can just kind of see how files sync. The one thing you'll want to pay attention to is you'll want to manage your storage space pretty carefully when you're doing a remote observatory, because you can fill up your computers very quickly. The thing I like about Dropbox is that I have all of these folders here, all this raw data in my Dropbox, and what I can do is just select all my folders, and I can say Dropbox and make online only. Now all of these files are not going to take up any space on my computer. They're just going to be on the cloud, and they'll exist physically on my editing PC and not the capturing PC. You're going to have to be constantly managing this data to make sure your stuff doesn't fill up. It's really nice at our observatory, at least with the fast Wi-Fi speeds, where we can just loop all these files right away, and then as you capture them, you can make them online only, and then they won't take up any more space on your capturing PC than they have to. That's how you get the data off. In the next sections of this tutorial, I'm going to talk more about astro imaging in a remote context, things like planning what to shoot, what you can do, maybe what your exposure times are going to look like, and talking about astrophotography from a remote context, because there's so many more possibilities than what you could do just by travel shooting. So I hope you guys found this video helpful, and I will catch you all in the next one.